Assalamualaikum everyone. So in this video, you are going to learn about subtopic 4.2 under the application of differentiation, which is extremum problems. Okay, so at the end of this lesson, you should be able to find the stationary points. So, stationary points. What is stationary point? So, stationary point is basically a point where the gradient, which is also known as dy dx and f prime of x, will be equal to 0. Alright, let's take a look at the example of graph I have over here. It's a smile graph, okay? So, I'm going to denote a positive sign for positive gradient and negative sign for negative gradient. Alright, so at this left side of this graph you have over here, the gradient will be negative because it's going down. So I'm going to write negative over here. So it's going to be negative all the way down here. And at this point, if you can draw a tangent line on this point, it's going to be a horizontal line like this, which is parallel to the x-axis. So this means that your dy dx will be equal to 0. Yes, exactly. Alright, and then after passing through this point, your gradient is going to increase, which is going to be positive. Alright, so positive all the way up. Okay, so this point over here I named as point A is what we call as a stationary point. So it is a stationary point because at this point our graph is neither increasing nor decreasing, it just stays, and our dy dx is equal to 0. Okay, let's move on to classification of stationary points. So there are two types of stationary points, which are turning point and also point of inflection. So the first type you have is the same graph I have explained in the previous slide. So your stationary point is going to be down here. Alright, so I name this point as point A. Okay, and then your second graph, your stationary point is going to be up here. So it's point B. Alright, so the first point A is called as a relative minima because the point is at the bottom, and then the second graph, point B, named as relative maxima because it's on top. Okay, alright, so why is it called turning point? So it is called turning point because for point A, from negative gradient meeting stationary point, it changes sign to positive. So this means that this graph is turned. So it's like this, and then meeting point A, it turns upward. Okay, and then for point B, it's going up, positive direction, positive gradient, going up until point B, and then it turns down. Okay, that is why it is called turning point. Alright, so the next type of stationary point is point of inflection. So this one over here, yes, exactly, is where your dy dx equal to 0 is going to be, because your tangent is going to be like this. Alright, so this is point C. I name this as point C, and then this one over here is going to be your stationary point for this graph. Alright, so the first one is called rising inflection and the second is falling inflection. But in this chapter, you are going to focus only on this type of stationary points, which is also known as relative extremum. Alright. Okay, now let us do an example. So find the stationary point for fx equal to x squared plus 5x plus 6. So we have already learned that a stationary point is a point where our dy dx gradient of the graph is equal to 0, which means that the first thing that you need to do is to find the first derivative. So your first derivative is going to be f prime of x equal to 2x plus 5. Okay, and then for stationary point, I'm going to write SP for stationary point. For stationary point, our f prime of x is equal to 0, and then 2x plus 5 is equal to 0. So x is equal to negative 5 over 2. Alright, so x is equal to negative 5 over 2. We have already found our x coordinate. Now we need to find our y coordinate. So you can just substitute your your x coordinate into this fx over here. Alright, substitute this one and this one to find your y. So f negative 5 over 2 is going to be negative 5 over 2 square plus 5 times negative 5 over 2 plus 6, and just press your calculator. Your answer will going to be negative 1 over 4. Alright, so which means that stationary point is negative 5 over 2, negative 1 over 4. So, what are the steps of finding stationary points? So, the first thing is to find dy dx, and then you need to find the values of x when our dy dx is equal to 0. And the final one is to find y coordinates by substituting our x coordinates into y. Okay, but don't forget to write back your x and also y coordinates in terms of point. All right. Okay, so example 2, find all relative extremum for the following function. So relative extremum is basically minimum, relative minimum, and also relative maximum, which means that you need to find all those stationary points which are on this function. Okay, so your first step is going to be finding the first derivative. So it's going to be 6x squared minus 24. Okay, so we need to let our f prime of x equal to 0 for stationary points to exist, and then it's going to be 6x squared minus 24 equal to 0. So factor out 6, you have x squared minus 4. Okay, and then you can bring 6 to the other side, and then factor out x squared minus 4, you will have x minus 2 times with x plus 2. Okay, so what is your x value? Yes, it's going to be, it's going to be x equal to 2 and also negative 2. Okay, so what's left for you to do is just to plug in your x values into this fx to find your y value. So you have f2 equal to, and then f negative 2 is going to be. Okay, so stationary points and alright, that's all in this video. See you in the next video. Bye bye.